Good evening. Today we are going to see the revision lectures for NPTEL. So we have tomorrow examination and then just revise the thing very fast, that is within 1 hour. So I am going to prepare 3 to 4 lectures in this. So now if you will see NPTEL first assignment carefully, then except this, in this question you have to find out UDL. In all others, if you will see, we are interested with equilibrium equations. So here we are interested to find value of bending moment at A. Means we have to go equilibrium equations, 3 equilibrium equations, summation fx equal to 0, summation fy is equal to 0 and moment 0. If you will see whatever exams I have given before this one, so questions are mostly parallel to the questions which are in the assignments, because we have syllabus and they are going to frame the questions as per the syllabus. Now when you are going to solve these questions, be careful. So we have this internal hinge, you can see here and you can see here. So moment about this E from left, and moment from left means CE portion is 0. Sorry, right, CE is 0, and from left we are going to be about E0 from left also. So same we have for D also. So moment from right D to C we have 0, and from A to D also we have 0. So when we will take moment about E0, then I will get value of RC directly, because we do not have any load and it becomes 0. Now when you will take moment about D, we are taking only right part. When we are taking moment about D, then we are going to get value of RB directly, because we are going to be RC0 and directly RB we will take, and we will get value of RB that is equal to 15 kilonewton. And then by taking moment about A0, we will get value of MA. So likewise, we have to solve these problems. So here also you have to find out that is maximum bending moment. So we know for maximum bending moment, we have to plot shear force, and shear force 0 point we have to find. How we will find this? You can take moment about C0, then we will get value of RB. And once I know value of RB, I can find shear force 0 diagram. So all these are related with your equilibrium equation. Means I have NPTEL assignment with equilibrium equations, and internal hinge plays important role in this. Now for this trapezoidal load, so that you have to, triangular load, you have to keep in mind total load we are going to be area of load diagram, half W into L by 3. And that you have to keep in mind. We always write at L by 3. No, so that you have to keep in mind, because questions a little bit we have to think, and we have this will be 1/3 of L by 3. And then we have to take moment about A0, and directly we will get half W into L by 3 into, we have to take L by 3 plus L by 3 plus L by 9, and then we will get value. So questions, if we will see, are very easy. We have to just think of this. In this also, we have to find out horizontal reaction at horizontal and vertical reaction, that is at D. And it is very simple. If I will take moment about C, now we are hinge at C. So that is given. So moment of forces and reaction on downward we have 0, and ABC part also we have 0. So to find horizontal reaction, if we will take moment about C0, then this becomes 0. And for vertical, you have to take moment about A0. So likewise, we have to go for this. Now then we have to go for this SFD. Now we are interested with shear force diagram. So now if we will see carefully, first we have to see here we have x to the power 0. So we have x to the power 1. And then we have to see, is there any other diagram with the same? Then if yes, then we have to go next. We have to find reaction at A. And that we can find very easily, as we have internal hinge over here. So we'll take moment about B0. And while taking moment about B0, we have to consider only part which is on left side. So we will consider part 2 meter only, not 4 meter, and we will get likewise. So we have this as 10 kilonewton per meter, and then we have reaction that is equal to Ra. And if we will take moment about B0, then we have Ra into 2, and that is equal to 10 into 2 into 1, and Ra we will get it as 10 kilonewton. And then if we will see, then we have moment about this 0. Then we have 10 kilonewton up. And if we will see at B, so we have 10 into 220 minus 10 minus 10. So we will have this diagram and no load in this one. So we do not have anything. So here we should have x to the power 0. So likewise, we have to see actually problem. Here also you have to take moment about B0. Again, you have to go with all total load. We have half into 8 into 2. And here we have to go total load half 12 into 3. And now we have internal hinge about B. So if we will take moment about B, we will get RC. And then we have to find out vertical reaction at A. And then simply apply Fy0. You will get at A and take moment about B0 left part. We will get value accordingly. So likewise, we have to find out the reactions which we have in NPTEL assignment 1. Here also it is very simple. We are going to be with half W into L. And then accordingly, we have to find reaction that is at A. And then we have to go maximum shear and maximum bending moment. So now first you have to keep in mind which problems we can solve easily. Should switch over to it first, and then you can go other problem. Here now number of independent. Here these are related with your basics, that is statically determinate, statically indeterminate. So likewise, now you can see here we have simple support here roller. This is mechanism. We do not have direct relate with truss, and therefore this is mechanism. So now here also we have to find the force. Now whenever we have to find force in any of the member, so we have to follow section method. And section method means we have to cut the section in such a way that remaining members should pass through this, and then only it becomes easy. So if I will say CF, then I will take cut like this. So what will happen in that case? You can see if we will draw the diagram, then we have diagram in this fashion. So just I will plot. So we have this diagram. So this we will have cut. Then we have this also we have cut. And then we have accordingly this diagram. I will not go with this diagram. So let us we are in this way. So this member DF FD is cut by this section. FD cut by this section. DE cut by this section. And then member FC cut by this section, in which force we have to find out, and simply take moment about D0. So these two unknowns will pass through it, and I will get directly value of FEC, and then we will have that value. So likewise, actually, but that we have to consider this part, because here otherwise, if we will consider this part, then you have to find reactions also. But if we will consider a part on this side, that is left side, then it becomes 0. So you have to extend it and then find the value. So we have this one, then we will have cut this one, we will extend it. Then we have another member, this member, and then we have this member again, which is cut by this, and we have to take moment about this. I will directly get force in FCT. So we have to check it in which joint, about which joint we have to find the members. So likewise, here we have only forces in truss members, and section method you have to prefer when you will go with this one. And section method is simple one. You have to first see in which member we have to find the force, take section in such a way that other two members should pass through it. So directly we can take moment about this. Or if you are in position to apply Fx0, Fy0, then you can use it. So these all, if you will see, we are with the trusses, and that we have to go for NPTEL assignment number 2. Now just I will revise what we have to go for. We have to first use three equation, Fx equal to 0, Fy 0, and then we have moment equal to 0. Then we have to go for static indeterminacy, ds E equal to R minus equilibrium equation, and dsi that is equal to m minus 2j minus 3 if we are going to be with trusses, and if we have, this is pin jointed, and if we have rigid jointed, then we have to go 3c. So for rigid jointed, dsi equal to 3c. That is most important, which we have to keep in mind. Then we have to go, if we will go for any truss, then you have to see how to go for forces in the members. And that now we are actually in position to go for this. I will just take truss and I will just show you how we will go for this. So now you can see this. Suppose we have this truss and we are interested. So we have A, B, C, D. I will just go through the section method and then we have this is 80 kilonewton. Then we have this as 60 kilonewton. And then we have this will be 90 kilonewton. We are interested to find force in BC. So what we will go, we will take a section in this way. So in that case, whenever we will go for section, we have to find the force. Now, if this is to all this, we have 2 meters, then we are going to get this reaction RF. So what we will get moment about A0. And that we will get it, that is minus RF into 4 plus 90 into 2 plus 60 into 2 plus 80 into 2. And that is equal to 0. And from this we will get value of RF. So if we will divide everyone by 2, then 45 plus 30 plus 40. And then we will get it as 115. So we have 115. Of one side we know all reaction. Now I will take a right part of the right part of this. So what I will get? So I will show it. Now try to understand this method. So we are in this question. And then we have this member. Now members which are not cut should not be considered. So this is 90 kilonewton. Now I have this reaction as 115 kilonewton. And then we have this member. Now which force you have to find out? Now we have 3. First we have FCB. Then we have this will be FDF, DB. And this will be FDA. Now suppose I have to find out in FDB. Now I can directly say, so let us I will consider tensile in this and I will apply summation Fy is equal to 0. So I have, so this angle is 45, FDB sine 45. This 60 is there, minus 60 plus 115 is equal to 0. I will get value of FDB. I need not require to go for all. Suppose we have to find out FCB. Then what we will take? Now we have 3 members cut. Out of these 2 members pass through the same point. You have to check it. Which joint is common in these both? So we have in these both joint D is common. So I have to take moment about D because these are the 2 other members. We have to find in FCB. Always assume tensile and then I will take moment about D0. Then what I will get? FCB will develop anti-clockwise minus FCB into 2. Then 60 passes through D, need not require to consider 90 plus 90 into 2 because we have clockwise. And then due to 115 anti-clockwise minus 115 into 2. And that is equal to 0. We will get value of FCB directly. So try to understand how we will go to the problems, then you will be in position to solve it. So equilibrium equations, that also is important. So any, suppose we have given this as simple support. So we have, let us this, and then we are interested. So this we have, and forces are given. So suppose this is given 60 kilonewton, then we have given this as 100 kilonewton. And here suppose we have again some UDL. And we are interested to find the reactions at A, which is fixed. Because now this is again you can see this is determinate. So you can have directly equation summation Fx equal to 0. I will get value of He. I will apply summation Fy equal to 0. I will get value of Va directly. And moment about A0, I will get values directly of Ma. So likewise, you have to see the problems carefully and then we have to solve it. Now, whichever problem you can solve very fast, first go to that problems and then you can switch over to the other problems. So try to understand first we have equilibrium equations, first assignment. So problems you will come on this. Second and third, we are with trusses. So in this, we have to find out mainly forces in the members. And that we have to keep in mind forces in members. So that is if you cannot find by section method, then you can have by joint method, but it will take time. If you have time, then you can solve this one. Again, you have to keep in mind your calculator is not allowed in the examination. You have to use the calculator given by them, which is online calculator. So we have this assignment 1, 2, 3, which are related with your equilibrium equations and trusses. So first we will stop here only, then we will go to the other assignments. So thank you.